Hi guys, today's problem is Task D of AtCoder Beginner Contest 259. Here is the problem. We have n circles and for each eye, the eye's circle's center is xi, yi, and it has a, a radius of ri. And also we have 2 points S and T, and these coordinates are expressed as Sx, Sy, and Tx, Ty, and these points are, are on some circles. Uh, we have to think. Uh, we, so we want to go. We want to move from S to T, only passing through the circumferences of these n circles. The question is to determine whether it is possible to go to T or not. So for example, if S is here, T1 is here, and T2 is here, then uh, you can move from S to T1 uh, like this way, or this way. Anyway, you can move from S to T1, but you can't go to T2. So if T is T1, the answer is yes. But if T is T2, the answer is no. And we have very important constraint, that is n is at most 3000. That means n is very small. We use it later, but now uh, uh, let's think about the problem with a few examples. So first one is this. Uh, we have 4 circles and S is here, T is here. You can move from S to T like this way. So the answer of this example is yes. And if example is this, the answer is no. Uh, uh, we can make this problem easier uh, when you think uh, to group these circles together. So for the first case, the first circles and the second circle, third circle, the fourth circle are all grouped together. And S and T belong to this group. So so I call this group 1. So so S and T belong to group 1. So this question, the answer is yes. But for the next example, we have two groups, group 1 and group 2, and S belongs to group 1, but T belongs to group 2. So S and T, uh, these groups are different. So uh, you can't move from S to T. So let's summarize this idea. If you have two circles and if these two circles intersect each other, so like this one, so so we should group the circle 1 and circle 2 together. But otherwise, I mean, if the two circles don't intersect each other, uh, you you don't do anything. So I mean, uh, the circle 1 is one form a group, but the the second circle forms the other group. So if you have too many circles, uh, like this one, 2, 3, 4, 5, 6, 7, 8, 9, da, da, da. So if you have too many circles, uh, what you have to do is the same. So that means you have to make groups. Uh, let's summarize it and let's write the algorithm. So first, fix I and j, and this means uh, we we consider the I circle and the j circle. We consider only two circles now, and then check whether these two circles intersect each other or not. If it is true, that means if they intersect really each other, uh, we have to group them together. But if it is false, you 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 don't do nothing. You don't do anything. And do the same process for each pair of ij. Uh, uh, so if you do it all, uh, you make that means you make all the groups, and then use a nested loop for 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 the process. But be careful when you use a nested loop, and you pay attention to the time complexity. But in this problem, we use a nested loop for n and n. That means the time complexity is at most n squared, but n is at most 3000. So 3000 squared is less than 10 to the 7th. So uh, that's enough to carry out. So this process is a process for making groups. And then uh, you have to answer this question. So first find the group S joins and the group T joins. If you know these groups, then check these groups are the same or not. So if the groups are the same, your answer is yes. But otherwise, the answer is no. So that's all about the algorithm we want to write. Uh, so I explain about how to write it. So first, I I explain this process. So how to check whether they intersect each other or not. And then if you want to how to group them together, uh, I recommend you to use a famous data structure to group something. That is union find data structure. Uh, I don't ex- explain about this data structure. Please Google it or see my code. And finally, I explain how to find the group S joins. So from now on, uh, I explain these two processes. So first, how to check two circles intersect each other. The first example is here. Uh, these two circles really intersect each other, and you check three variables. That is, one is a radius of the I circle, and Ri and Rj. That is the J circle's radius, and D is the distance between uh, the centers of these circles. So from this picture, you may find uh, this inequality R1 plus Rj greater than D. But if two circles don't intersect each other, this like this picture, uh, the inequality is false, so totally opposite. Ry plus Rj uh, less than D. So for the first condition, you have to write this inequality, but that's not sufficient to check two circles intersect each other. So you have to think about this picture. This is very important, but uh, sometimes overlooked. So this picture is where a circle contains the other. In this case, we have this inequality. So what you want to know is uh, how to check two circles intersect each other. Uh, so you have to think about the opposite. So this inequality, and then we check this when our two circles really intersect. So in this case, uh, this inequality actually holds. So uh, so summarize it, and so if the first condition Ri plus Rj less greater than D, and the second condition, as I said earlier, but you have to add this third condition. That's because uh, the second condition is that the circle Ci contains Cj, but uh, we have to think about that the Cj contains Ci's case. So Ci contains Cj, but we have to think about Cj contains Ci. So you have to add this condition. And if these conditions are all satisfied, then the answer, so I mean these two circles really intersect each other. But otherwise, two circles don't intersect each other. So let's write it. But I have tips for this process. So these three conditions are equivalent to these beautiful conditions. So you can integrate these three conditions into this this condition. I recommend you to write it this sentence. So for the next, we have to think about how to find the group the point S joins. Let's think about the ith circle Ci. The Ci's equation is this. So if S lies on the Ci, uh, the equation really holds. So if you check this equation and it really holds, then S really in CI. But otherwise, S is not in CI. So, so you can check where. So this means you have a you have a process for checking uh, whether S is in CI or not. So let's do the same process for each I. So you use a loop. Uh, so that's all about the algorithm. So finally, just use this. Just write this algorithm. Uh, so my code is on the description. So so check about it. Thank you for watching.